are said to be disjoint. Disjoint. The word here, disjoint. Now the last major topic of this lecture, before we get into problem solving, is how do you actually prove in practice that two sets are the same? How do you prove that set A equals set B, that the elements of the two sets are the same? How can you actually prove that? Well, the usual way is to show that, well, here it is here, that A is a subset of B, and that B is a subset of A. If you can prove that, then you've shown that A and B are equal. See, the only way that these two conditions can be true is that A equals B. Okay? So to prove that, you do two little proofs, smaller proofs, by showing that A is a subset of B and that B is a subset of A. Okay, so let's actually, I've got two examples here. This is probably, it's a fairly easy lecture, just a whole bunch of definitions so far. So I guess, in relative terms, these two little proofs here are the most difficult part of this lecture. Alright, you're asked to prove that two sets are equal, and in the first proof, proof A that we're trying to do, that your first set is the intersection of A and B, and you have to prove that that's A when you start off with the knowledge that A is a subset of B. Okay? So if A is a subset of B, then A intersection B is A. Now I can draw that in terms of a Venn diagram. It's sort of easier, more intuitive to see. Okay, so A is a subset of B, right? So let that be B, and let's say that's A inside it. Okay? So A is a subset of B. So looks like that. So the intersection of A and B. So the intersection, where A and B, that would be this, right? That's the intersection of A and B, is A. Well, yeah, right, you can just see it. Intuitively, visually you can see it. But how would you actually prove that, given the definition of a subset? Now I'll... so if A is a subset of B, let's do a little bit of revision here. Go back to the definition of a subset. So if for all x belonging to A, x belongs to B. Right? That's the definition. That's the definition of a subset. So all the elements, all the members of A belong to B, right? Like here. All right. Well, let's actually try to prove this. Now, I've written out the proof here because so it's easier for you to follow. Okay. Now, to prove the equality of two sets, you have to do two proofs in effect. You have to show that one's the subset of another, and the other is the subset of the one. So you go both ways. Now the only way those two can be true is if the two sets are equal. So to prove they're equal, we will do that and that. Okay? Now in this case, here's like the left-hand side and here's the right-hand side. So let's let's start with this one. So take some element that belongs to A intersection B. Let's just call it X. So it's any element belonging to this. Okay? Now, if this element X, if it belongs to the intersection, now by definition of intersection, it means that X belongs to A and to B. Well, so obviously it belongs to A. Okay? So any element belonging to this belongs to A. Following me? Any element belonging to this intersection belongs to A and B, so it belongs to A. So any element belonging to this belongs to A. Therefore, this is a subset of A. Hope you're following me with that. If not, rewind and go back. Right. So if X belongs to A, I'll go the other way. So now we're trying to prove it going, if A subset B, now B subset A. So there's two parts. So now if X belongs to this, then this is the definition of the subset. So if A is a subset of B. What does that mean? It means any element here belongs to this. So if X belongs to A, it belongs to B, right? X belongs to B. And that means X belongs to A intersection B. Because if X belongs to these two sets, A and B, then X belongs to the intersection of A and B, right? So if X belongs to A, X belongs to intersection. So by definition of a subset, that means that A is a subset of A intersection B. Right? So we have the intersection's a subset of A, and A is a subset of the intersection. So we have our two parts, there and there, and the only way these two can be satisfied is if they're equal. So that means that A intersection B equals A. Right? So that's the end of the first proof. Now the second one, you're asked to show if the intersection equals A, then A is a subset of B. How would you prove that? Well, let's see. This one's a bit tougher to start with. Well, let's take an element X of A. So X belongs to A. Right? Now you're told that A is equal to this. Right? You're told that. So if X belongs to A, X belongs to the intersection. Okay? So if X belongs to A, because of this, then X belongs to this. If X belongs to that, X belongs to that. So X belongs to the intersection. So that means X belongs to B, right? Because that's what intersection means. So if X belongs to the intersection, X belongs to both of these. That's what the intersection means. So that means that X belongs to B as well. Okay? So if X belongs to A, X belongs to B. Now that's the definition of a subset. Therefore, A is a subset of B, which is what you're trying to prove. Well, that's the end of the theory part of this lecture, and the next part I'll solve some problems.